Hey mathletes, it is time to math it up. With Math It Up 2000, we are going to cover similar triangles and finding their missing measures. And just let me use my new toy. Yay, let's go. All right, so as we begin our work with similar triangles, we want to look at the differences between congruent triangles and similar triangles. So we have congruent triangles. Congruent shapes, we use this symbol for congruent. Congruent is kind of like geometry's equal, right? Congruent shapes share some qualities. They are the same size. You can see there, they're the same size. And they are the same shape. And you can see there they hold the same shape. Now, I could put my finger on this and turn it 90 degrees, turn it a little bit downward. It wouldn't matter. It would retain the same size and same shape as that other triangle. So something to note here is that the size is determined by the side lengths. So if the lengths of the side are the exact same, that's going to help the size. The shape is determined by the angles. So the corresponding angles are all the same measure. So the corresponding sides are the same measure, and the corresponding angles are the same measure. And that's what makes them congruent. Then we also have similar triangles, similar shapes. It doesn't have to be a triangle. We just happen to be talking about triangles today. And similar triangles are indicated with that little squiggle, which is just the top part of the congruent sign. So we might say triangle ABC is similar to triangle EGF. Now, once we see that somebody has said those two triangles are similar, then we know something to be true. We know a couple of things to be true, actually. We know that all the corresponding angles are the same measure. Just like with congruent triangles, the corresponding angles have the same measure. So if this is 35 degrees, this is 35. If this is 70, this is 70, and so on. That's what gives the two triangles the same shape. The other thing that's true is regarding the sides. Now, the sides, you can see clearly the corresponding sides are not the same measure, but they do have a relationship nonetheless. They are proportional. And if you remember scale factor, they share the same scale factor. So if you go from, let's say this side is a 5 units long, this side is 10 units long, that means the scale factor is 2. We'd multiply that 5 by a 2 to get 10. And then this one might be 4. And the same scale factor will apply. 4 times that scale factor of 2, this side would be 8 units long. And this might be 3. And the scale factor of 2 would apply there. 2 times 3, this would have to be 6. So if they're similar, their corresponding angles are exactly the same. That's what gives them the same shape. And though they don't share the same size like congruent triangles, they have proportional size. So their corresponding sides are proportional. So that's the difference there. Again, just to reiterate, if they're congruent, they share the same size and shape. And if they're similar, they share the same shape. They are not the same size. All right, let's carry on. So now we're going to take a look at a set of triangles. Now you see they're not exactly lined up in the same way. One's a little bit turned, and that's okay. That doesn't affect anything. We can still look for these relationships. So let's begin with angles. So let's say this is 45 degrees here, and we're told this one is 85 degrees, and this is x. Well, we would be able to find the measure of angle E because we know that the three angles in any triangle must add up to, put that down, angle E must add up to 180 degrees. So I'm sure you've already figured out what the answer is, but if we're going to go through the algebra properly here, this would be 130, and we would subtract 130 degrees from each side, 0 plus angle E, and the measure of angle E is going to be 50 degrees. And of course, we can translate. I'm going to fill that in there. 50 degrees. We can translate all those angle measures, the corresponding angle measures over here, 45 degrees, 50 degrees, and 85 degrees, because we know that when they're similar, they have the exact same angle measures for those corresponding angles. Now let's talk about side measures. Get rid of this. Not quite. There we go. All right. So on to side measures. We're going to start by giving ourselves 5 units there, and 12 units here, and 7 units here, and 15 units here. Okay, so we have some side measures now. We'll have this side here, the length of this side, we'll name that x, and this y. We could also name it by the 2 endpoints. Nope, that is an F, not an H. That would also be side GF, or this could be side line segment AC, but we'll use X and Y for our purposes right now. Okay. All right, so now we have a proportional relationship. Again, that scale factor is sometimes really simple to recognize. It's always a multiplier. Sometimes it's not, and we have to use proportions. So let's look at this scale factor right now. So I'm going to go from this side to the corresponding side here and say, what is my scale factor? I'm going from a 5 to a 15. And again, it's always through multiplication. Well, we know that that is times 3. 5 to 15 is times 3. So it looks like this is 3 times the size of this triangle here. So that makes it pretty easy for us then. We have this 7 here. So we know we're going to be multiplying by a 3. That would give us 21 here as our y. And finally, we know we're going from that number to this number with a times 3, a scale factor of 3. So what times 3 is going to give me a 12? Well, we know that's a 4. And again, we could have done it the other way. If we wanted to go from the 12 to the x, then we just have to do the inverse here, which is the reciprocal, or we would say 12 times 1/3, the reciprocal of 3, so that we can get to that 4. Either way works, however your brain thinks of that most easily. But what if the numbers weren't so recognizable? What would we do then? Well, we can set up proportions to help us if that's the case. So the way that I prefer to do this, and this is not the only way to do this, but I like how this sets up in my mind, is we would take the relationship we know. So we have a 5 for our small triangle, and the corresponding side is 15. So as I talk about a lot, in proportions, there's a relationship here, and there's also a relationship here and here. Here, these are the small triangle numbers. These are the large triangle numbers. This is one set of corresponding sides, and then this would be a second set of corresponding sides. And of course, one of them has to include our variable. So we use this set, and now we're going to try to find x. So our small triangle contains the x, and our large triangle in that corresponding side is a 12. And one of the reasons I like doing it this way is I can see that scale factor real easily from the small to the large. That helps. But let's say, again, we didn't recognize that so easily. Let's go ahead and do our cross multiplication. And this is 60. And we will divide both sides by 15 to turn that into a 1. 1x is just x. And of course, this is 4. And we already knew this was a 4. We figured that out with just a simple scale factor earlier. But that's how we would set up the proportion. And now we're going to do that one more time for the other missing side. Again, if we didn't know or arrive at that scale factor so easily, we would have to use these relationships. So again, a relationship that I have to use a relationship I have first. So small is 5, and I was given the 5 and the 15. The large is 15. 5 is to 15 as, and then I have 7 in the small is to y. And if you can think proportionally, it helps. 5 is to 15 as 7 is to y. What's this unknown? And again, I know this is very easy for you to do in your head, but it's just illustrating this. So 5y equals 105. It's 15 times 7. Divide both sides by 5. 1y is just y, and of course this turns out to be 21. And we knew that from earlier because that scale factor was so easy to deal with. But proportionally, this is what we're doing. 5 is to 15 as 7 would be to our missing number. All right, we're going to have to give ourselves some confetti because that was pretty awesome. Okay, so now we're going to do one more together here before we get to check and correct on your own. So often we will see problems like this with similar triangles. When there is a small triangle on top of a larger triangle, they are similar. The other way these often look is like this. You will see this a lot too, where this angle and this angle are the same measure. This angle and this angle are the same measure. It's just a smaller version of this angle completely upside down. And this angle and this angle are the same measure. And then we can also look at sides. This side would correspond with this side. This side would correspond with this side. And finally, let's see, this side would correspond with this side. And pro tip here is I just like to draw the second one so it makes sense right next to the other one. And what you have to do is just make sure you're pulling down your numbers correctly and recognizing what this should look like. All right, but we are going to look at the other type for our example today. And here we go. So in this type of a triangle, you can see these two sides have the same 1 slash because they are the same measure in this case. So let's get some measurements in here. So a lot of times what you'll have with these kinds of similar triangles is you'll have maybe a full measure of this side, and then maybe they'll give you this measure, and then they might give you this measure, and maybe some variables here. So let's look at this. So not a bad idea here, like I said, to draw your two triangles out. Make sure you're really aware of what's going on here. So what do we have and what do we not have? So these are both 30 in the large triangle because these are the same length. Now how do we figure out this measure? We have 30 here. This is 20. And the difference is y. The difference here is 10. So these two measures are 10. So again, the full length was 30. They gave us the 20. This has to be the rest of it, which would be 10. They gave us this measure for our small triangle, and this is the other measure that we're having to solve for. So I think you can see very easily again, we have a scale factor that's easily recognizable. We're going from a 10 to a 30. That is times 3, and therefore this would be times 3 or 15. But we're going to set up a proportion just to practice doing that. So again, small over large triangle. And this is going to be one set of corresponding sides, and this will be our second set of corresponding sides. And I usually start with the corresponding sides that give me the information I need. So we're going to say 10 is to 30, small, large, 10 is to 30. And again, I like to do it this way because it shows me that scale factor real simply right there. 10 is to 30, as in my small triangle, 5 is to x. 5 is to x. Again, I know the math is easy on this, but we're going to just play it out here just so we can see how this all works one more time. That turns into a big 1. X comes down. And x, of course, is 15 units, and we already knew that because the scale factor was easy for us to recognize. All right, well, I'm going to have to give us confetti on that one, too. That's another awesome problem we did. Okay, so now we're going to get to our check and correct. So let's just talk about this for a moment, and then you're going to go ahead and try this problem, get it all done, and then we are going to have you start the video again and check your work and correct your work. All right, so what we have here is an old school way of measuring very tall things. It involves shadows, and you can learn more about that. But for our purposes, we have two triangles here. We have a triangle here. We have a triangle here, which is embedded on top of a triangle here. So it's the same situation we were presented with basically in the last problem. So let's see what we have here. Okay. So what is happening here is they're sharing this angle here. Okay. So this is 8 feet here, and this is 5 feet. And to figure out how tall this tree is, we have 24 feet as this length here, and this is our unknown. But we can use what we have here to figure this out. So please stop the video now. I'd like you to find the missing measure and also try it with a proportion. Even though I know these numbers are not that difficult to figure out, try setting up the proportion in the way that we talked about just to practice. Okay, we'll see you in a few minutes. All right, welcome back. Okay, so let's think about these two triangles, what they look like. And again, I know this is probably quite simple for you, but we're going to also talk about the proportion. So this is a 5 feet. This is our unknown number of feet. This is 8 feet, and this is 24 feet. Now, you see that scale factor is quite simple. Again, it's a 3. 3s are very popular today. So the corresponding side from here to here, we're multiplying by that 3. So we know that that 5 feet times 3 is going to give us 15 feet as our unknown measure. But let's set it up in a proportion. So let's take our small over our large. We're going to take the corresponding sides we know about and use our unknown in the second set. So where are our corresponding sides we know about? They're right here. So 8 feet is to 24 feet as small. 5 feet is to some unknown number of feet. All right, so let's just pull the numbers here. 24 times 5. So 8x is going to be equal to 120. Divide both sides by an 8. And 8 goes into 12 one time with 4 left over. 8 goes into 40 5 times. And again, we said earlier it's 15 feet, but this proves that x equals 15 feet. And hopefully you got that right. And if you didn't, please make sure that you correct that work. It's good for your brain to go through that correction process. And finally, we have our on your own problem. So lots to figure out here. You're going to figure out the measure of angle x here, the measure of angle y, where is it, here, the measure of angle z here, and then you're going to figure out the length of line segment TR, that's from here to here, and the line segment that is SR, which is here to here. So do what you know how to do, work through the problem, and do it while it's all fresh in your mind. All righty, well, peace, love, and pie to all. And I don't know, one more confetti, what do you think? All right, bye-bye, everyone.